Awesome. Thank you all for coming. I am going to focus almost exclusively on joins with a couple other extra little pieces. Just doing last week, the last class session reminded me, and I guess all of us, that joins are worth more than an hour of discussion. So we'll go into it now. And yep, that's it for the agenda. And then for the schedule, I'm planning to do more joins today, and then 2 weeks from now, hopefully, this might change, but I've enlisted Javed to help me out with this. I'll probably do most of the talking, but what I want to do, I've provided that SQL site, which is, I think, pretty good for, as a sandbox to practice. But Javed expressed interest in installing his own, as well as a couple of people. And of course, Javed is using a Mac, so he's using Parallels, so he's got an even harder task. And he's gone ahead and installed all of SQL Server, helped him out a little bit, but it's mostly him on his own. And then I've got all of that test sort of fake data that I've been using to go over some of these concepts, which, while SQL Zoo is fine, I appreciate that it's probably hard. It's a little bit of a stretch to do those examples, but not be able to do my examples that I'm doing during the class. So we're going to take some time out, get outside of the actual mechanics of SQL and play with installing this locally. I'm also exploring Amazon Web Services, setting up a SQL server there. And I haven't had much time to look at that, but when I do that, I might be able to just say, okay, install any sort of SQL tool like SQL Server Management Studio, and then just connect to the remote site. So stay tuned there. You might even get to skip installing SQL Server locally. But I want this to be something for everybody. Excuse me, I have a cough. Then on 9:14, I'm sticking to this every 2 week thing for now. We'll plan to get into aggregates. That's counting and summing and minning and maxing and all that sort of good stuff. And once we've gotten there, you will have a fairly complete tool set for querying data. And then we'll get into some of the other stuff like views and things like that. But probably after aggregates, once you've got that under your belt, we'll likely want to have yet another discussion on joins. If anyone's looked through that SQL Zoo homework at all, a lot of the join homework includes things like summing and counting and grouping by, which we haven't even covered yet. So probably 3 full classes at least on joins, which is as it should be. Oh, look at that. Man. Okay, so just to recap, a lot of this is a repeat of what we covered last week, but we're going to go a little deeper into it. So we've got our relationships here, and these are my students table and addresses table, and they relate on students.studentID, students.studentID, to addresses.studentID. So as you can see, Edwin Millard has a student ID of 112233. That relates to addresses table on this key here. And so using this relationship, we can figure out where Edwin Millard lives and where Clara Pratt lives. So there we go. Now, one thing I'm going to cover really quickly in the slide, but we're going to get to a bit later in my examples, is that I have in my database 1 students table and 1 addresses table. However, I can join a table to another table as many times as I want. So I'll demonstrate here. I've got my students table. I've got 1 addresses table, but now I'm doing a join on addresses where my address type equals M. I'm doing M for mailing and P for permanent. So I can join students to the same one addresses table, but I can do it twice. So I can get students and mailing addresses and students and permanent addresses. And that comes in handy a lot. So we're going to get into that pretty quickly. Just one more quick reminder of our ecosystem. We've got students, addresses, courses, enrollments, and terms. And so I've got one set of relationships here with students to addresses and students to enrollments, all based on the student ID key. And then I've got another set of relationships here, course term and course related to my terms table, and then courses related to my enrollments table. And it's this little indirect table here that enables me to join students and courses. I've got one example of that prepared for you, and we might speak about that a little bit more. All right. Let's get on to the stuff. Where are we here? Okay, cool. Just got to get my notes here. All right, so what we're going to do is we're going to revisit all of our kinds of joins. So what I have, and this is just a repeat from last week, but I only covered inner joins and left joins last week. So we're going to cover inner joins, left outer joins, right outer join, full outer join, cross join, and self join. And we'll see what all of that means. I'm putting self in quotes because this is sort of a special case. Basically what that means, sort of similar to my addresses slide just a few slides ago, is you can join a table to another table multiple times, but then you can also join a table to itself. So we'll look at that in a bit. And then what I'm going to focus on primarily are inner joins and left outer joins. These are just going to be brief forays. They're important to know about, but I would say that in my experience, I use inner joins and left outer joins predominantly with a good, healthy slathering of self joins. Right outer joins, full outer joins, not so much. Cross joins, almost never, and you'll see why. So, and sorry for those watching the video and on the call, that's my neighbor's dog. So, just to reintroduce the inner join, I'm going to bring in my addresses and students again. So, students.student ID. Probably go through this piece a little quickly because I did it last week, but just to refresh everyone. Thankfully, this autocomplete means I don't have to type so much. All right, so I'm selecting all of these things, and even though these came up in autocomplete, you'll see all of these have these squiggly red lines because for now, this is an invalid statement because where is students? What is students? What do you mean by students? And what do you mean by addresses? In SQL, I have to say from students, and I have to spell students correctly. And once I've done that, a lot of my squiggly lines go away. But then I want to join on addresses. So I'm going to say inner join addresses on students dot student ID equals addresses dot address ID. So once I've interjoined those, I can get all of my students and all of their corresponding addresses, even though addresses live in a different table. So just a couple of things to point out here. you might sometimes see just join instead of inner join, and that is fine, and you'll see it in a lot of my code too. Join and inner join are equivalent. Join is just sort of shorthand for inner join. But if you see just join, that means inner join. I'm going to try to be good about using the full syntax here, just for clarity. On a lot of online examples, you'll see mostly inner join like that, and not join. But just know that they're equivalent. Similar with left outer join and right outer join, you can get rid of the outer here, at least in SQL Server. That might not be the case in all database systems. So I'm thinking it's probably safe to just do the full syntax. Now, just a couple of things here that I want to sort of belabor. One thing is you'll notice that I'm qualifying all of these fields with the table name, and including here in my join clause and in my select clause. I don't really have to do that, except when I do. So I'll illustrate here. I can get rid of students.firstname. I can get rid of students.middlename, students.lastname. I can get rid of most of these, in fact. And run it again. I've got 8,007 rows. Run it again should be the same. Yep, same number of rows. This works just fine. However, the reason why I like to qualify my column names regularly is because what if I don't qualify this student ID one? Then all of a sudden I get an error. Which student ID? I don't know which student ID you're talking about. And it's the same here if I say just student ID. This is another error there. I'll tell you about that in a minute. But basically, my syntax error here is which student ID. I don't know which student ID you're talking about. And now I've got that error twice because I'm not fully qualifying it. So I say students dot student ID to fix that. Put that here as well.
Should that be addresses dot address ID?
Nope, it should not.
Okay.
And that was something I was going to belabor, but I didn't do this on purpose. I probably could say that I did it on purpose to make sure you're paying attention, but no, this was an accident. And hopefully that illustrates that you can do this all your life and still make these sorts of mistakes. If you'll recall, if I just look at a few records from addresses, I've got address ID, but I've also got student ID. And in my convention, I'm saying addresses.studentID relates to the students table with using that students ID key. So what I really want here is inner join addresses, students join to addresses on students.studentID equals addresses.studentID. Absolutely spot on, Rob. And that's the thing. So that gives me 4,825 rows. That's the correct result. When I was running it with addresses.addressesID, that's they're both numbers. Student ID is a number. Address ID is a number. But so this is syntactically correct, and this will run. And SQL has no idea that this isn't what you mean. Maybe with some better artificial intelligence, we could get something like, I don't think this is semantically correct, even though it runs. But yeah, be very careful of this sort of thing. And as we go forward, we're going to talk about a couple of tricks that I like to use to verify my results. I'm going to go ahead and clear this out. One of the things, so back to the aliases, this is why it's handy to establish a routine of putting your table aliases on your columns quickly, or your table names. If I'm just playing in my sandbox, exploring my students table, I can run it and everything's fine, and I don't have to qualify anything, as you'll see, because like with the example of student ID, there's no ambiguity now because I'm only selecting from students. It's once I join to addresses that I run into problems. And so my general workflow, and pretty much anyone who's doing SQL stuff, you're not going to write the script that does what you need it to do right away, right? You get a request from like the admissions director or something like that that says, give me all the students that blah, 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 and blah, 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 and all this criteria. So, maybe you have to sort of refresh your memory on how the database works, and you start selecting from the students table or the papers table or the name master table or whatever database you're in. And you start building up your query table by table, join by join. If you start doing that, and if you don't have the habit of prefixing your columns with the table name, you will eventually start running into these errors. And when your query gets sufficiently complex, this is not a good example of a complex query, but when it gets sufficiently complex, which it will, this can be harder and harder to troubleshoot. So I get into that habit early and often, just to maintain my sanity a little bit. One other thing, though, that you can do is you can alias tables. So I could say from student S, and join addresses A if I wanted to, just to save some typing. Now, of course, I have to redo all of this because now the interpreter says, well, what's students? I don't know what students is, but I do know what S is, so let's do that. And it's these aliases. Right now, they seem like, oh, that's handy. So you don't have to. You can do slightly less typing. That's good. But these aliases come in really handy a little bit later when I'm going to be doing a query that grabs the student mailing address and student permanent address, and I'm going to have them running across these columns here. So we'll get into that. But just have this under your belt. Aliases. You can alias your columns. I've seen some people, even at Dynamic Campus, I've seen some people alias things like this, and they might join something else. I'm not going to fix this. This is syntactically incorrect now, but I won't fix that. But as you can see, some people just alias A, B, C, etc. Don't do that. That's really hard to read. I don't like that. If I'm going to alias my tables, I want to give them a meaningful name. Students being signified by S or STD, or even leaving it without the alias, just call it students, is way less confusing than these sort of arbitrary alias values. A lot of people do that just to save on typing. But again, when you write SQL, remember someone later is going to have to read your SQL. That might just be future you. This gets impossible when the queries are complex. So, minor soapbox moment. Let's get back into joins. So, I'm going to get back into, let's see how many undos I can do here. Forget it. Copy paste. Another quick point. I got a lot of sides here. SQL Server, SQL, Microsoft SQL Server SQL is generally case insensitive almost all the time. But Eric Larson reminded me a couple of weeks ago that when you're selecting from colleague I don't know if we have any colleague folks on the call, but colleague SQL folks, but when you're selecting from colleague, your table names actually have to be uppercase. So just an FYI there. I do that when I'm querying from colleague data a lot. You know, like, these tables exist. Why am I getting a syntax error? And it's because these are lowercase. Anyway, I'm going to, instead of, I ran a wild query somehow. That's having to cancel. Let's just open something new. Okay, so here's my inner join. Now instead of an inner join, 4825, I'm going to do a left join, left outer join. So what a left outer join does, if you'll remember, is it says, give me everything, every row from the left side of this statement, students. And in the cases where student's ID matches addresses.student ID, give me those records as well. But in the cases where they don't match, just put null. So all of these nulls here are cases where there is a student ID, but there is no corresponding address ID. Now, a practical use for that, one practical use for that is I might say, I want to find all of my students that don't have an address. So I can add a clause here where addresses.student ID is null. And if I run that, I see that I have 77,555 records where there's a student but no corresponding address. Now, in a real system, that might be a real problem. For here, I don't care, but this is one handy trick to find problematic records if you're doing data cleanup or something like that. Now, let's go back to inner join. Let's do an inner join, get rid of that, and look for students where they have an address in California. Now, I know I did all of this stuff last week. We're going to go further with it this week, though. I just wanted to start back where we left off. So now what I have here with an inner join is every student who has an address, and that address is in California. And that's 359 rows. But as you've seen, I've got a whole bunch of cases where I have students who don't have an address. So maybe I want to do some stuff with that. So if I instead say left outer join and run the same thing, that was 359. And again, I'm at 359. Even though I'm left joining, putting my addresses logic here in the where clause still filters it down so that only get people with addresses in California. However, if I change this where to an and, this and now becomes part of this left outer join statement. So what this means is, let me move these down just to clarify. I'm left outer joining students to addresses, so give me all students. They have addresses, and the address either matches this criteria here, students.student ID equals addresses.student ID, and addresses.state equals California, or it doesn't. And if it doesn't match this criteria, just give me a null value. And that gives me about 81,000 rows. So what this is, and I misspoke last week until Phil corrected me, so thanks, Phil, if you're out there. This gives me every student it pretty much gives me every student that I have, but it shows me their address if their address is in California, and shows me null if it's not. So probably somewhere in here, I've got some addresses in California. This is kind of a lot of rows, so you might not see all that. But so this is every student, show me their California address or don't. Whether they have a non-California address or no address at all, show me null. And if they have a California address, show me California. So I'm going to copy this and make a similar query. The thing that I said I wanted to do last time was I want to give everyone who has an address in California or who doesn't have an address at all. And this is not that. Instead, I'm going to go back to my where clause. And I'm going to put an or statement here. So if you recall from an earlier query I ran, when I ran just addresses.studentID is null, that showed me all of my students who didn't have an address. And so adding this California clause shows me all students who either have an address in California or have no address at all. It's about 77,000. Fine, we're going to start playing with proving that all of these assertions are true. But in any case, I'll go ahead and do an order by. Let's go ahead and do a descending order by. And let's go ahead and qualify state, just because that's generally a good practice, even if it's not necessary. Okay, so I've got all of my students who have an address in California or who have no address at all. The difference between this statement and this statement in terms of how it looks on the screen is subtle. But the difference in the values it returns is not so subtle. And so this is something that you are going to want to start practicing, is what is the difference when I put my criteria in my left outer join clause and when I put my criteria in my where clause. And just the quick summary of that is when my criteria is in the left outer join clause, all of this falls under the same jurisdiction. So I'm joining to addresses, but only addresses of a certain type. And I'm left outer joining. But this all comes under the same jurisdiction. Whereas in this case, all of this runs essentially, and then this where clause, once this is all run, this where clause filters it down. So it's almost like an order of operations sort of thing. Really, there's very little I can say to make it super clear. I just, listening to myself, I'm like, I'm not sure I would understand that if I just heard that for the first time. This is where you really need to start playing and sort of understanding, getting an understanding with yourself how it works. But we're going to do some stuff to sort of help you in your experimentation when you have your own SQL environment. SQL Zoo or your own enterprise environment, at your school that you're working at, or the one we build yourself that I'll help you with 2 weeks from now.
Quick question.
I want to take a quick, go ahead, Rob.
No, actually, Joanne. So you have
Joanne.
you have your or in parens. Is there a reason when it's that simple?
Yes, there is. Absolutely. These parens aren't really necessary in this case. And Joanne, just to prove that I wanted to take that aside, I've got this whole other thing prepared to show you or examples. So good, thank you. Yes, these parens in this case aren't necessary. So I've got 77914. If I run this again, 77914. But I, as a practice, really prefer to put my OR clauses in parens, and these parens, what they do, sort of like any arithmetic operation, is they force the order of operation. So if I had more clauses in my where clause here, more statements in my where clauses, more logic, I'm not really sure what would get organized when, and I want to make sure that these get evaluated as a unit. So I will demonstrate. So this is my initial query that I had. Again, 77914, where I have addresses.state equals California and addresses.state equals null. Now, so that's, I'm just going to put a little comment here to remind myself how many records I got. Now here, I've got an extra piece of logic in my where clause. I've got addresses.state equals California, or addresses.state is null, as before. And then I've got and last name equals Jones. So if I run that, I've got 309 rows. And now I have the same set of logic as I do here, but without the parentheses. Let me bring this back up so you can see that this is exactly the same except missing this one piece of parentheses. So this query gave me 319 rows. This query gives me a different number of rows, 678. And if anyone's seen those like complicated online arithmetic quizzes where it's like, what is the result of this? And, 50,000 people comment and everyone disagrees. It's all in the order of operations. And instead of going over the order of operations, I'm going to say skip that and put things in parentheses. So let me just talk a little bit about what this does. What this is doing is it's saying, so my end here, give me everyone who lives in the state of California or where the state is both null and the last name is Jones. And you can see that kind of just sort of anecdotally. All of my Joneses here have no address value, and all of my people with an address value are not named Jones. We could go more rigorously prove it, but you can sort of see it's kind of obvious here. If I have a null for my state, guaranteed I'm going to have a Jones. And most likely this is not what you want. And why keep order of operations in your head? What really happens is like an OR clause causes your, the way it actually works is that every OR statement you have, everything between the ORs, on either side of the ORs, is grouped together. So SQL says, okay, this is one group, and then after the OR, this is another group. But that doesn't make sense to me. And you have to know what data you're looking for and what you want to understand that. And parentheses are really the only useful way of forcing precedence. So instead of saying, give me everyone with an address in California or state is null and last name is Jones, instead I want to say, give me everyone with a state in California or not, and for all of these, make sure that their last name is Jones. So you'll see with these results, I only have Jones, and that's what I wanted. Does that make sense at all? Really just think back to arithmetic. Your multiplication and your division happens first, and then your addition and subtraction happens after that. But maybe you want that to be a little different. Let me see if I can conjure up an example here. Select 5 times 7 plus, let's do something easier, 2 times 3 plus 4. Okay. Someone tell me what the result of this is going to be. Anyone? Is it going to be 14 or 10?
10.
10, okay. Why, whoever said that, thank you. Why is it going to be 10?
Because 2 times 3 is 6 plus 4 is 10.
Right. So why isn't it 14? Because why can't I do 3 plus 4 is 7, and then times 2 is 14?
You need the parentheses.
You need the parentheses. It's all in the precedence. And granted, there are mnemonics to help you remember that, but why bother with that? Just use your parentheses weapon. This will be 14. So perfect. Thank you. And the or and and clauses work in exactly the same way. Okay. So back to this, where I've got my addresses.state equals California and addresses student ID is null, and there's a difference between this and this, where I have my where clause outside, and my whole select query is where my where clause has jurisdiction, or my clause here in the left outer join, where this statement only has jurisdiction here and filters down the addresses table before I outer join it to the students table. So what I want to do, I'm going to really just excruciatingly belabor this, just so that we can sort of play with what it is like to prove something to yourself, prove the data is correct. So here's my initial query. Let's actually start with this query here. Let's just get rid of this. I don't need it. Okay. I'll run this, and I've got 77,914 rows. Just put a note to myself of that. Second, I can find the number of students. Just do a select star from students, inner join addresses on student.student ID equals addresses.address ID. Student ID. Sheesh. I stopped doing that. Where addresses state equals California. Okay, so this is an inner join here. This gives me all students with an address in California and only students with an address in California. No students where there is an unknown address. Okay, so that gives me 359 records of students with an address in California. Okay, third, let me find the number of students with no address at all. I can actually borrow this one and just remove the California bit. So this is students that have no address. I covered this a little earlier in the call. I run that. I'm left outer joining, and I'm just finding anyone where there isn't a corresponding address record. That is 77555. And so in theory, this is everyone with no address at all. This is everyone with an address in California. And I think that this is everyone with an address in California and no address at all. And so in theory, if I add all of these numbers together, select 77555 plus 359, I should get 77914. Awesome. And let's say I want a comma in there just for fun. Awesome. Okay. That was an aside, but I like to have these little Easter eggs in here for people who are bored with my lecture format. That's handy. Okay. One thing, though, is that Joanne, the last time, asked me to count my records. So instead of running this and looking down here to see a count, I'm going to change this up to just say, instead of selecting all of these things, let's do count star. Awesome, 77914, it's the same. So I'm going to keep doing that, count. And again, I mentioned last time that doing something quick on counts would be a disservice to counts, but I've changed my mind. So this is a quick preview of what you're going to see in our aggregate class. But these numbers, results, should match my comments here. Awesome. And a lot of times that's what you want to do. You want to find just what's the number of results. And what if I do this? Put these both in parentheses and say select will this work? Select this number plus this number. 77914. Awesome. And so finally, just one little extra piece of the puzzle. If I say select this number minus select this number, subtract it from these two numbers, I should get 0. Oh, no, I don't. Okay. What do I do? Oh, maybe if I put these in parentheses, so add these up first to get 77914, or whatever that number was that this returns. Run this. There we go, 0. So this is just something I like to do when have sort of a complex logic problem and I'm, rewriting a query or something like that, and I know that there's X number of students, and so I know that my query should return X number of students, and you can play with that. You can use count without understanding all of the other intricacies of aggregate functions. You can use count here to just help prove your assertions. All right. So here you go. Now, let's do something real. I've spent 45 minutes on that. I'm going to do something else. Okay, so if I select from addresses, this is where joining and table aliases and everything like that, this is where it really comes in handy. So one thing you might notice is I've got address types of M and address types of P. That, as I mentioned, is just my made-up standard for permanent address versus mailing address. So what that means is that I probably have some students here who have both an address type of M and an address type of P. What that means is that in a lot of my earlier queries, I was selecting for students and maybe getting 2 rows for a given student. If a student has a mailing address and a permanent address and they're different from each other, then I'm going to get 2 rows if I try to select them. What if I want across my columns here their permanent address and their mailing address? And maybe I want their permanent address, if it isn't null, I want to replace it with mailing address or something like that, some sort of logic. So I'm going to cover that really quick. So I'll just sort of add this let's see. I don't want to do that. Okay, so what I'm going to do, I talked about aliases. I'm going to say, just add this part here. Save myself a little bit of typing. Okay, last name. And I'll say from student. And now I want to join on addresses, but I want to join on addresses twice. And you'll see what this looks like. So I mentioned earlier that I can alias any table that I want. So I'm going to left join addresses, but I'm going to call it permanent. Yeah. And I'm going to say on student dot student ID equals permanent dot student ID. I can't refer to addresses here. I have to refer to permanent because I've given this instance of this table the nickname permanent or alias. I'm going to say and permanent dot address type equals P. Then I'm going to left join on the addresses table again, but this time I'm going to call it mailing. On student's ID students dot student ID equals mailing dot student ID. And mailing, not address ID, it's address type, sorry. Mailing dot address type equals M. So now I'm joining on the addresses table twice, but I'm filtering one of my addresses tables to just address type of P and another to just address type of M. So now what I can do is display permanent, and just to keep it short and simple, I'll just do state. But I could do the whole address if I wanted. Mailing dot, anything I have in here, I can concatenate them, I can get all of them, I can do whatever I want. Mailing dot state. Run that. Now I have students with, let's actually give these columns an alias as well. Call it term state, mail state. Now I have a bunch of folks with some permanent addresses and some mailing addresses, or one or the other, or both, or neither, etc. And now I can do some cool stuff with this. One is I could change this to inner join if I wanted to. And this gives me just people with both term states and mail states. But that's probably not going to be what you find in the real world. And definitely not in my junky data. So I'm going to left outer join again, so I get every student. And then what I'm going to do is I'm going to bring back the coalesce statement from an earlier lecture. I will say, what I'm going to do is I'm going to say something like this. Maybe I have this backwards, but I'm going to just say, if they have a mailing state, show it. But if mailing state is null, let's show the permanent state. And if the permanent state is null, let's show unknown. And let's call that my mailing state. So I want their mailing address. I'm going to try to get that first. But if this doesn't exist, give me this one. And if this doesn't exist, well, then we've got some problems. And throw your hands up in the air. So there we go. Now I've got just one value for mailing state. And I've got either unknown or a state, who knows where it comes from. I have some state for everyone that at least has some sort of address. Then what I can do if I want is this same coalesce statement, I can put that in my where clause. So I could say something like this, where is not equal to unknown. So there are other ways to do this, of course, but this filters out anyone who doesn't have any sort of address at all. So now I have all of my students who have some sort of address. And I don't care if it's permanent or mailing. I prefer mailing, but I just need an address for these people. And I'm just going to make the assumption that if they don't have a mailing address, that they at least have a permanent address. And anyone outside of that, in this case, just leave them out. I don't want to see them.
Would you have got the same result? Sorry, would you have got the same result if you left off that unknown? Just close the paren at the end of permanent state and then execute it?
I wouldn't get the same result here.
No, get rid of the equal unknown as well.
But what I would have to do, and I wouldn't get it here, I have to add one thing. This is actually syntactically correct. I have to make a Boolean logic statement here. So, but what I can say is not null.
Okay.
Exactly. So thanks. Yeah, very good question. And that does give me the same. I didn't keep track here, so maybe I didn't prove this rigorously, but yeah, I'm going to say that this statement is the same as the adding unknown in here and then doing not equal to unknown. Absolutely. Yeah. Okay, so we don't have much time left. I want to do a couple of quick things. If anyone needs to leave, just go ahead and leave. I'm recording this, of course, so no hard feelings there. But I want to take about another 15 minutes and go over a couple of things. It was inner joins and left joins that I really wanted to focus on, but I just want to talk about a couple more things. So again, leave if you want, stay if you want, and if you leave, you'll see the recording. So right joins, I'm just going to copy paste this in. Right joins are just like left joins, except instead of saying, give me all students, and if they have an address, great. If they don't have an address, then just give me null. This says, give me all addresses, and if there's no corresponding student record, and in my junkie data, that's a real possibility. I got a lot of address records with no corresponding students. This says, give me all of my addresses, and if there is a corresponding student record, great. If not, forget it. I run that. I get about 14,481 rows. Now, I almost never use the right join because you can do with a left join exactly what you can do with a right join if you want. So if I take the same thing here, copy and paste that, but instead of doing a right join, I just move students over here and move addresses over here and change this to a left join. Wow, I did a bad job with that. Students here. So this is a right join with addresses on the right. This is a left join with addresses on the left. So my results from this was 14,481. My results from this should be exactly equivalent. And it is. So for me personally, right joins hurt my head. I avoid them. I like the left joins better. And you can do everything you need to do with a left join that you could do with a right join, vice versa. So if you prefer one or the other, you can stick to that one and do pretty well. There may be cases where you need to left join in some cases and right join in other cases with really complex queries. Fine, but I will say that in my work, left outer join is probably the main join that I use besides inner join. So now what I'm going to do, so that's all I'm going to say about right join. I'm not going to belabor anything about that. You can play with it if you want. What I'm going to do now is full outer join. A little different. This is basically a right join plus a left join, or a left join plus a right join. This says give me everyone in students, and if they have an address, great. If they don't have an address, give me null. It also says also give me every address, and if there's a student, great. And if there's no student, give me null. So this gives me 92,000 plus records. this might come in handy. I don't use this one often either, but there may be cases either in some sort of special kind of report or in cases where you're just trying to figure out the data. And you might be saying, what's the difference if I full outer join a couple of tables versus inner join versus left join versus right join, all of that stuff. For me personally, it's kind of just a way to get to know a set of tables in a database. But you might see these things out in the wild. Okay, my last thing, and this is the fun part, this is a cross join. I think I'll do self joins later. So the cross join, this is just a thing you shouldn't do. If I say select star from students, join, I could do a couple things. Select star from students, and I used the comma notation last time. Select star from students and addresses. So just give me everything from both tables. This is called a Cartesian join, and what it does is it says, give me, for every row in students, for every one row in students, give me every single row in addresses. That's a lot. So what it means is if I do select count star from students, I get 81458. I do select count star from addresses, I get 14,000. So what this means is if I just run this, it's going to say, it's basically going to give me this number of results, 81,000 times 14,000. And so it is going to give me, put these in parens, select this. That's going to give me, what is that? That's like 1.2 billion records. I can actually even call it cross-join here. So if I run this, my machine's going to go crazy. It's going to take a really long time. In fact, I tried to see it just for fun, and it went for way too long. So let's just say, I'm going to just select students.studentID. If I run this, it's going to take a long time, and I'm going to have to cancel it. But what I can do is I can say select count star from this, give this an alias, this select query. I run this, I should get about 1.2 billion, and I do. Okay, great. So this works. I can get a count. And that was quick, but if I run this, I'm going to end our talk with this. It's going to start executing. I'm getting a lot of duplicates, as you can see. And this is going to take, if I left this running, this would take half an hour maybe longer. This is huge. You're going to encounter this a lot, especially when you're new to this and not used to joins. If you don't add your join criteria, if you're joining from two or more tables, or if you add it in a way that's sort of incorrectly, that sort of subtly gives you this cross-join, Cartesian join, whatever you want to call it, your query is going to take a really long time. You're going to get way more results than you expected. And the number of times that happens to you is going to be greater than you probably think right now. This happens a lot. And in fact, if you're ever interviewing for a SQL job and someone says, you have a query that's taking a really, really, really long time to run. Now, there are cases where your query is legitimately complicated and it takes some time to run. But the question is, you have a query that's taking forever to run. What is the first thing that you look at? And if you say the first thing is, I messed up my join criteria and I've ended up with a cross join or a Cartesian join, that's That is the first answer that everyone who asks that question is going to expect. Now, you can say things like, like I don't have enough memory on my SQL server. I need to, re-index some of my tables. I need to defragment some of my database, all of this sort of stuff that's all real and important sort of DBA stuff. But this is the first answer of why is my query taking forever to run? This is suspect number one. And on that, I'm going to go back to my PowerPoint and do the homework. So for all of you who are doing the SQL Zoo homework, great. Please continue to do so, and please do send me questions about it. I actually do all of the homework myself as well, and it takes a long time. So, if you don't do every single one of them, I was like 6 hours on a Sunday going through like a couple of these, and that's not actually a good way to spend a Sunday. So I have sympathy for people who don't have actual lives and then are busy at work. But start playing with this when you can, whenever you can. An earlier homework assignment, maybe 2 sessions ago, I had the using null, but I said only answer questions like 1 or 2. That's because it got heavy into the left and right joins. Revisit that if you have some time, and do all of the questions, and give that a shot. 2 weeks from now, for those of you who are interested, we will be going over installing your own SQL server, setting up your own database to match mine. Anyone who doesn't have any interest in that at all, just skip the class, but anyone who wants to, come on, you're always welcome. Any questions before I stop the meeting? Oh, hey, look. It didn't take forever. I just got an out-of-memory exception. Cool. Imagine if this was a server and not just my own workstation. You'd probably get an angry email from Eric Larson. All right, I'm going to go ahead and stop the recording.